Okay, in this video we're going to talk about surds. Now, we are going to talk about surds in a different point. When we look at the section on logs, we're going to revise everything that was on surds on junior cert, and there's going to be a number of questions with surds in it. However, for the moment, this is the only thing that I would consider to be in the algebra section on surds. You could be given a question like this where you're asked to solve for x, and you have the square root of 3x minus 5 plus 1 equals x. Obviously, in order to solve for x, I need to eliminate my surd. In order to eliminate surds, you square it. If I multiply this by itself, then the surd will be gone. So your goal in every question we do in this video will be to get rid of your surd by squaring it. However, at this stage I can't square it. It's not in the right form. At the moment, the problem is there are two terms on the left, and if I square it, I'm not going to get rid of the surds. If I squared everything at this stage, the left-hand side would be double brackets. I'd have to multiply the first thing in the first bracket by the second bracket, second thing in the first bracket by the second bracket, and I'd find that I don't actually eliminate my surds. I'd still have a root 3x minus 5. So what we need to do before we square both sides is we need to isolate the term with the surd. So I don't want to square everything now. What I want to do is subtract 1 from both sides, so that I've isolated the surd on the left-hand side. And once I've this, now I'm happy to square both sides. Because I have to square the right-hand side, and if I square the right-hand side, it's relatively easy to get x minus 1 by x minus 1. And if I square the left-hand side, the surd will simply be eliminated. And then I'll just have normal algebra. So let's square both sides here and see what happens. The square root of 3x minus 5 to be squared is simply 3x minus 5. X minus 1 multiplied by x minus 1, if you multiply out your brackets, you will get x squared minus 2x plus 1. So you need to recognize now that you have an x squared, an x, and a number. So what I want to do is move everything to one side because I have a quadratic equation. If I moved everything to the right hand side, I would have x squared minus 2x minus 3x plus 1 plus 5. If I now group all my like terms, my quadratic is in fact x squared minus 5x plus 6. What I can do now is I can simply factorize. The factors here are x minus 3 times x minus 2. What I'm now going to do is add each factor equal to 0 and find values for x. I can say that x minus 3 equals 0 or x minus 2 equals 0. So my answers here are x equals 3 or x equals 2. However, in these questions, you have to verify your answers. So in every single question where you have a surd, you have an algebraic surd, you have to verify your answers. So now I'm going to investigate. If I sub in x equals 3, does it fit into the first line? If I sub in x equals 2, does it fit into the first line? So the first value I got was x equals 3. And I'm simply going to rewrite my original line, except everywhere there's an x, I put in a 3. So I get the square root of 3 times 3 minus 5 plus 1 is equal to 3. 3 by 3 is 9 minus 5 gives me the square root of 4 plus 1 equals 3. Root 4 is 2, and obviously 2 plus 1 is equal to 3, so that one is true. X equals 3, that's an acceptable answer. For now I try x equals 2, I just rewrite this line again. I get 3 times 2 minus 5, the square root of all of that plus 1 should be equal to 2. And in this case, 3 times 2 is 6 minus 1 gives me 5. And the square root of 1 is just 1. Obviously 1 plus 1 does give me 2, so that's an acceptable answer as well. So let's have a look now at one more example, and then I'm going to give you a few questions to try yourself. Okay, but the problem is if you get a question on surds, it's more likely to be like this, where you have two separate surds. In the previous part of the question, I told you need to isolate the term with the surd in it and then square both sides. Problem is it's impossible to isolate both of the surds here. If you have two separate surds, the only thing I'm going to be able to do here is I'm going to need to square both sides twice. I'm going to need to first eliminate one of the surds and then try and eliminate the other surd. So in this case, the surd on the left-hand side is the only term on the left, which means that if I square both sides straight away, at least I'll have eliminated one of the surds. So what I'm going to do is simply square both sides to eliminate this surd. The problem is I have to multiply this out as double brackets, so I'll be left with a surd on the right hand side. Okay, so what I've done here is I've simply squared both sides. The reason I did it is because when I square the left, I simply get 3x minus 2. But the problem is when I square the right, I have double brackets. So I multiply the first thing in the first bracket by the second bracket, second thing in the first bracket by the second bracket. Root x minus 2 by root x minus 2, the surds cancel and I get x minus 2. Root x minus 2 by 2 is plus 2 root x minus 2. Then I have 2 by the surd, which gives me plus 2 times the surd. And then I have 2 times 2, which is 4. So what I decided to do to go from my second last line to the last one was to group the like terms. I have a minus 2 and I have a plus 4. That adds up to plus 2. I have 2 plus 2 times the surd plus 2 times the surd, which adds up to plus 4 times the surd. Now now it is progress. Like this line is more appealing than this line because there's only one surd at this stage. In order to eliminate this surd, I need to isolate the term with the surd. In other words, I need to get the x plus 2 to the other side. So I'm going to rewrite this as 3x minus 2 minus 2. In other words, the x comes across, becomes negative, and I subtract 2 from both sides and I get an extra minus 2. And I can say that that is equal to 4 times root x minus 2. 3x minus 1x is 2x, and minus 2 gives me minus 4. On the right hand side, there's nothing I can do for the moment. So now I've isolated the term with the surd in it. The fact that there's a 4 in front of the surd isn't really a problem, it's fine. What I want to do now is I want to square both sides again in order to eliminate this surd. So notice that we had 2 surds at the start. I squared both sides to eliminate the surd 3x minus 2. Now I'm squaring everything again to eliminate the other surd that I have, root x minus 2. So if I square the left hand side, it's 2x minus 4 multiplied by 2x minus 4. That's going to give me 4x squared minus 16x plus 16. If I square the right hand side, I have to individually square the 4 and then square the surd. 4 multiplied by 4 is 16, and root x minus 2 multiplied by itself simply gives me x minus 2. And now I'm happy. I've eliminated the surds and I just have basic algebra. So I'm going to rewrite this line at the top and we're going to take it from there. So it's basic enough algebra from here. I simply multiplied out the right hand side. 16 by x is 16x. 16 by minus 2 is minus 32. I moved everything to one side and wrote it in the form of a quadratic. 4x squared minus 32x plus 48 equals 0. I realized then I can divide everything by 4 and get x squared minus 8x plus 12 equals 0. If you factorize and solve this quadratic, you get x equals 6 and x equals 2. However, because this is a surds question, I need to go back to the original line and I need to sub in x equals 6 and x equals 2 to investigate if they fit into the original question. If the original equation had surds, in order to get the full marks in algebra, we need to sub in to verify our answers. The original question was written up here, and in red here I have 2 different scenarios. So my first possibility is x equal to 6. So I sub that into my original equation and it worked out as 4 equals 4. So I'm happy enough. X equals 6 is a valid answer. So that one's okay. The second answer I got was x equals 2. And when I sub that one in, I end up with 2 equals 2. Obviously, again, it's the same number, so that one's valid as well. So this one actually has 2 valid possibilities. X could be equal to 6 or x could be equal to 2. So now that you have a taste for these questions, I'm going to give you a couple to try yourself. So to practice this material, I'm just going to give you 2 questions. The first question, I want you to solve for x if the square root of 2 minus 7x plus 2x is equal to 0. And the second one is far more difficult. I want you to solve for x if root 5x plus 1 plus root x plus 1 is equal to 6. So I want you to pause the video now and attempt these questions yourself and then compare them to my solutions. Okay, so the first question I gave you here was to solve for x if root 2 minus 7x plus 2x equals 0. So I realized that there's a surd here, which means I'm going to need to square everything at some point. But before I square everything, I want to isolate the term with the surd. So I subtracted 2x from both sides and I got this. I then decided to square both sides. Because if I square root 2 minus 7x, I simply get 2 minus 7x. And if I square minus 2x, I get plus 4x squared. I then realised I had an x squared, an x and a number, so I moved everything to one side and I had a quadratic equation. I've factorised and solved my quadratic, and x is worked out as a quarter, or x is worked out as -2. So now I want to sub these values into the original question to investigate if these fit into the original. So what I've done here is I've subbed in x equals 1/4. If x equals 1/4, the original question would become 2 minus the square root of 2 minus 7 times a quarter plus 2 times a quarter equals 0. 2 minus 7 times 1/4 is simply 1/4. So I have the square root of a quarter plus 2 multiplied by a quarter is a half. And then the square root of a quarter is a half, so I get a half plus a half equals 0. Clearly a half and a half is 1, so in that case that one is not true. I have to eliminate my first answer, which was x equals a quarter. And now I'm going to investigate if the other one is true. If I subbed in x equals -2, it worked out easily enough, everything cancelled and I got 0 equals 0. So obviously in this case I've only got one valid answer, which is x equals -2. Okay, so the second question I asked you to solve was root 5x plus 1 plus root x plus 1 is equal to 6. This is a more difficult version because there's two different surds. It's impossible to eliminate all of the surds in one go, so what I want to do first is isolate one of the surds and then square both sides. So I did that by rearranging it as root 5x plus 1 is equal to 6 minus root x plus 1. I decided now to square both sides because when I square the left hand side, the surd is gone. But the problem is I have to multiply out the right hand side as well. So the right hand side became double brackets, and when I multiplied out my double brackets I got 36 minus 6 times the surd minus 6 times the surd, and then minus root x plus 1 multiplied by minus root x plus 1. Minus by minus is plus, and when I multiply something by a surd, the surds are cancelled, so I just ended up with plus x plus 1. What I've done then is I've simply grouped my like terms. 36 and 1 adds up to 37. Minus 6 times the surd minus 6 times the surd adds up to minus 12 times the surd, and I have an x as well. At this stage, my goal is to try and isolate the term with the surd so that I can eliminate my second surd. So what I did was I moved the other terms to the left hand side, and I end up with 4x minus 36 is equal to minus 12 times root x plus 1. And now I'm ready to eliminate the second surd by squaring everything again. So I'm going to rewrite this at the top. I'm going to square both sides and I'm going to try and solve this equation. So what I've done is I've taken the left hand side and squared it, taken the right hand side and squared it, so as to eliminate the surds. 4x minus 36 multiplied by 4x minus 36 is 16x squared minus 288x plus 1296. If I multiply minus 12 by itself, I get 144. And if I multiply root x plus 1 by root x plus 1, I simply get x plus 1. So the right hand side becomes 144 times x plus 1, which if I multiply in my brackets, I get 144x plus 144. And now I have an x squared and x, and I've got a number. So what I decided to do was to move everything to one side because I clearly have a quadratic equation. When I grouped my like terms, I got 16x squared minus 432x plus 1152. I can divide everything by 16 and get x squared minus 27x plus 72 equals 0. If you factorize and solve your quadratic, you get x equals 3 or x equals 24. But they're not necessarily both correct. In order to investigate if these are accurate, I need to sub these two answers into the original question and investigate if it works out. So my answers were x equals 3 and x equals 24. If I sub in x equals 3, I end up with 6 equals 6, so it makes sense. I'm happy enough with x equals 3, that's a valid answer. My other answer was x equals 24. However, when I subbed in 24 instead of x, I end up with 17 equals 6, which is clearly not true, which means that x equals 24 is not a valid answer. So just the moral of the story there is there's only so many different ways that the surds questions can come up, and I think if you know you just need to isolate a surd before you can square both sides, then you're fine. If there's a surd in the original question, assume that the marking scheme requires you to sub back into the original once you get to your answer.